video, we're going to talk about velocity versus time graphs. Last time we were working on the distance versus time graphs, and we drew out the position versus time graphs for all four types of motion moving along the x-axis. And we identified that the slope of the position versus time graph is velocity. We're going to go through that for a velocity versus time graph. Since slope is change in y over change in x, well, first let's identify what's on which axis. So velocity is on the y and time is on the x. So you can go through and label all four of these. Let's just do them all at once, so that we have those labeled, because don't want to overlook that. And now when we go to find the slope, we can say, well, if this is the y-axis, change in y is change in v. Change in x is change in t. Well, delta v over delta t is the definition of acceleration. So acceleration is the slope of a VT graph, just like velocity is the slope of a position time graph. This is very, very useful going forward. So the other thing that I want to make sure I mention is that even when you don't have numbers, most people find it very useful to create some sort of scale on the velocity axis in order to better understand what's going on. So if you say that this is -5 and this is 1, 2, 3, 4, 5, +5, and do that for each of these 1, 2, 3, 4, 5, so that you have some values to use, it's a little bit easier to then talk about constant speed, increasing speed, decreasing speed. And if that's not given to you on a particular problem, feel free to do that. Make up some numbers so that you have some reference values. Because again, you can't memorize your way through these problems. It's just not possible. All right, so let's do the tour going away first. We're going to be moving in the positive direction. And in all of them except for the first one, velocity is positive. So where is the positive region of this graph? Well, all the positive velocities are above the x-axis. So all this region that I'm highlighting, these are positive values of velocity. And positive velocity means you're moving away from the origin in the positive direction. So that's why I highlight it, just so I can keep my focus. Okay, when velocity is 0, well, velocity has to be marked 0. The y-axis is the value of velocity. So when velocity is 0, velocity remains 0 all the way across when you're at rest. There's no change. Here, velocity is positive and acceleration is 0. If acceleration is the slope, then having 0 acceleration means slope must also be 0. A 0 slope is a horizontal line. So let's say I was going at a constant speed of 2 meters per second. Well, I would have a horizontal line at positive 2 meters per second. If I were going faster, maybe I'm going positive 5 meters per second. If I'm going slower, maybe I'm going 1 meter per second. All of these are moving away from the origin in the positive direction at a constant speed. For the next one, we have velocity and acceleration. Those are both positive. So we're going to have a positive slope in the positive region. So a positive slope in this region looks like something like this, which should make some sense, because if you look at it, you're going 0 meters per second, 1 meter per second, 2 meters per second, 3 meters per second, 4. You're increasing your velocity in the positive direction. Now, if I had a less steep slope, I'm still moving with increasing speed, but now I have a smaller acceleration because my slope is smaller. This is a bigger slope, so I have a bigger acceleration, still increasing speed, but I'm doing it more quickly. Decreasing speed means I have to start with a big value, and it has to get smaller and smaller and smaller. I have a negative acceleration, therefore I have a negative slope. But you can also use velocity values. They have to be positive values, but they have to get smaller and smaller. All right, let's do towards. Now we're going back towards the origin. That means that I need to work in the negative region of my graph. So I need negative velocity values. So I have to focus down here, right? Negative velocity, negative velocity, negative velocity means all these graphs are going to be in this region. Of course, at rest, we're not moving, so we still maintain our zero graph, right? Our zero velocity. Here, we've got a negative velocity. Let's say I'm going negative 3 meters per second. Acceleration is 0, therefore slope is 0. Right? This gives me a value of velocity. If I'm going more quickly, I would have a bigger value. If I'm going more slowly, I have a smaller value. The closer to this time, the x-axis, the smaller velocity is. Now, since that's the case, here I'm starting at rest, then I'm going -1, -2, right? I'm increasing my speed in the negative direction. This is really hard for people to understand because negative numbers in physics only mean moving in the negative direction. So if you want to know how the numbers are increasing or decreasing, then you just look at the value. So -1, -2, -3 like that only tells you it's moving from 1 to 2 to 3 to 4. The number's getting bigger in the negative direction. If I'm decreasing speed, I need to have a positive slope and a negative velocity. So negative velocity is down here. Positive slope is going back this way. So we have a positive acceleration means positive slope. Just like here, negative acceleration meant negative slope. So here, notice that in this graph, both lines converge towards zero velocity. So you're decreasing speed. Here, both lines go away from zero velocity. You're getting faster and faster. So again, we're not going to memorize this stuff. All you're going to do is know that the definition of acceleration gives you the slope. Now, the area on a velocity time graph actually has a meaning, because to find area, we're going to do base times height. And base times height here is going to be, base is going to be time, height is going to be velocity. So that is your displacement. So even if you're going to do the area of a triangle, that would be 1/2 base times height. So you'd get 1/2 times t times v. The t times v part is still going to be your displacement. So what that looks like is the area, let's say, of the object that's moving at 2 meters per second. This area here is how far it traveled. So velocity time graphs are so useful because I've got velocity values off the y-axis, acceleration values from the slope, and displacement values from the area. So I can get all that information off of one graph. And here I would, let's say, find the area of this shape. That would give me the displacement when it was moving at increasing speed right along this, right, with this positive acceleration. You can do it in the negative region too. If I was going to find the area, notice it's between the graph, the line you drew, and the x-axis. So I would find the area here. So the area is 1/2 base times height because it's a triangle. And I could easily figure this out because I could go, if this was all, each box was 1, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 seconds. And it would be 1, 2, 3, 4, -5. Right, would be my velocity or the height of that triangle. So that would be -27.5 meters. So you could actually figure out, oh, I traveled 27.5 meters in the negative direction. So we'll do a ton of practice on this as we go forward.